Hello student, welcome once again in our 7th standard lesson number 9 rational numbers. In these lessons we can start our today's sessions with introduction, and there is a exercise 9.1 and 9.2 we will discuss in our next sessions. So as you know, ready with your notebook, pencil, erasers and necessary things. Before starting our today's sessions, let's do warm up exercise. Thank you. Now listen here, in our lesson number 9 rational number, what the introduction is there. Introduction means you can know about the numbers. So numbers are written here in a heart. Some numbers are negative, some are the fractional, some is 0, some is a 2, 3 upon 5, etc. So number counting 1, 2, 3 is called the natural number or counting number. But when you add the 0, that will become a whole number. Isn't it? Okay. But can you remember? You are now aware of negative numbers also. That's a minus 1 by 2 is new number for you. Yes, you are knowing minus 1, minus 2, etc. Number line you did in last sessions. It means last year. But you also knowing about the fraction. A fraction has the numerator and denominator. We are knowing about this one. Whenever the numbers are written in these forms, we can say it's a fraction. Same way here, we can use it, the numerator and denominator, but here it's called the rational numbers. We can say the numbers can written by P upon Q. P upon Q. In this format, we can say this is a rational number. And here, the numerator is either 0 or a positive integer, and the denominator a positive integer. You compare two fractions, found the equivalent forms, and studied all the 4 basic operations of addition, subtraction, multiplication and division. So rational number also can do these things. Clear beta? Yes, very good. Now, need for rational numbers. Earlier, we have seen how integers could be used to denote opposite situation involving numbers. For example, if the distance of 3 km to the right of a place was denoted by 3, then the distance of 5 km to the left of the same place could be denoted by minus 5. If a profit of rupees 150 was represented by 150, then the loss of rupees 100 can be written as minus 100. Yes, my dear student, that is the point. There are many situations similar to the above situation that involve the fractional number. You can represent a distance 750 above sea level. That means 3 upon 4 kilometer can be represent 750 meter. Below sea level in kilometer. Yes, why not? Sure. Then after you can simplify. Simplified means you can cut it 3 upon 4. Yes, correct. 3 upon 4 kilometer. System included such numbers. This fractional number, it is not a fractional number. It is neither integer nor a fractional number. We need to extend our number system to include such numbers. So this is the main difference between the fraction and rational numbers. It is showing the parts. Fraction is showing the part of the whole, and here it is represent the two phenomena, two things in a rational number wise. So we are having the natural number, whole number and integers, correct beta? And then after rational numbers. Rational number can include all type of the numbers. 0, positive number, negative numbers and also a fractional numbers. Students, these are very useful. Yes, a decimal number are also a rational number. 0.7, that means given 7 upon 10. Can we write like that way? Yes, we can write. So, we can divide it also and get the final answer. Yes, my dear student, that's why 0.75, it gives a 3 upon 4. Next one, 9.3. What are rational numbers? The definition of rational number are here. The word rational arises from the term ratio. Yes, ratio, no, ratio. You know that a ratio like 3:2 can also be written as 3/2. Here, 3 and 2 are a natural number. Remember these things? Yes. Similarly, the ratio of two integers p and q, where q is never become a 0. Q is not become a 0. Understood, students? Q will not become a 0. Got the idea? Q will not become a 0. Q p upon q, where q is not become a 0. Is how to read out this one? Q is not equal to 0. Very good, students. So you are knowing about this thing now. P upon q format is the rational number, where p can be positive number or 0, but q never become a 0. These things you have to keep it in mind. Is 3/4 also a rational number? Yes. Minus 3/4 also is a rational number. Both are the integers. So many are there. We can get these types of all the things are the rational numbers. First is a negative numbers, also a rational number. 3/4 and minus 3/4, both are the rational numbers. So don't forget it. Oh, very nice. 1 and 2/3 are the rational number. Is the rational number? Yes. 1 2/3, that means a 5/3. Good. Or decimal numbers also we discussed previously. 0.5. 0.5 means 5/10. 2/3. That means 23/10. Same way 0.333, which gives you a 333 divided by 1000. Clear? Then you can try the blue color. I think so you all are having the textbook, either a physical or a PDF format. Try it and see. Otherwise you can see from here and try to it. Is the number 2/3 rational? Think about it. Second, list the rational number. Now, numerator and denominator. Dear student, we are knowing the numbers are written above the line is called the numerator, and number below the line it's called the denominator. Here, minus 3/7, or you can say 3/7. 3 is the numerator and 7 is the denominator. Yes, correct. Look at here. Numerator is a negative integer and denominator is a positive integer. Numerator is a positive integer and denominator is a negative integer. Also possible. Numerator and denominator both are negative number. Also possible. Numerator and denominator both are positive number. It is also possible. At least it should be a positive or negative. But one thing is that q, denominator, never become a 0. Q is never become a 0. Got the idea? Otherwise, you can simplify it and get the answer. Are integer also a rational number? Why not? Any integer can be thought of as a rational number. For example, the integer minus pi is a rational number. Why? Because minus pi is the numerator and 1 is the denominator. We are knowing if any number is not written, then it should be a yes. 1. Same way, 0 can be also rational number. Why? 0/1 or 0/-1. That is also 0. So, the rational number include integer and fractions. Equivalent fractions, students. New topic is here, like as a equivalent rational numbers. Equivalent fractions means you already did these types of thing in lower classes. See, the number is written here 2/3. What is the 2/3? Rational number can be written with different numerator and denominators are also 4/6. What is the 4/6? Nothing. It's a simplified form of 2/3. 2/3. Same way, minus 2/3 can be written as a 10/-15. Now cut it. What will be the here? 5 1s are 5, 5 2s are 10. And downside, 5 3s are 15. Can we write like this way? Have you seen I am writing here on the board? Yes. What is left here now? 2/3. That is our previous one. So both one are equal. So we can say these are the equivalent fraction of 2 upon 3 or minus 2 upon 3. Isn't it? 4 by 6 or 10 by 15. Same way fractions equivalent, here equivalent rational numbers. Easy? Yes, my dear student, it is so easy. Again we can do 10 upon minus 50 is equal to minus 10 upon 15. The final answer remains the minus 15 upon 10. Sorry, 10 upon 15. Final answer remains like this way. Can you write like this way or 10 upon 15? Isn't it? Or you can write 10 upon minus 15. All the meanings are same. Easy? Correct. Same way here, try this. One box is given. You should have to find out what the operation can do. Before that, we can check out what is the real finalized answer of 10 upon minus 15 and minus 12 upon 24. Isn't it? Yes, 12 upon 24, that means 1 upon 2, and minus 12 upon 24, that is minus 1 upon 2. Same way, 5 by 4 is equal to dash upon 16. A box is written here. The downside 16 become, how it become 16 beta? Before that it was 4. So what do you have to multiply with that? Yes, correct students, 4. So 4 4s are 16 and 5 4s are 20. So first answer will 20. Regarding the second one, numerator became a 25. So how it become a 25? 5 में से 25 कैसे बन गया बेटा? Yes, 5 में से 25 बन गया वो 5 into 5. Same way, 4 into 5. What will be the answer there? 4 into 5 will give you a 20. Yes or no? Next one, 5 become a 15. तो नीचे क्या आएगा बेटा? X. How it become X? So before that it was 5 upon 4. 5 become a 5 3s are. Multiply by there. Here also you can write 4 into 3. That will be the answer 12. That answer will come as a 12. Is it or not? These are called the equivalent fraction. Last but not least, second question also we can discuss. 3 upon 7 is there, and then after equivalent fraction is become a 14 denominator. How it become a 14? Think about. Same way here, 10 upon 15 and minus 12 upon 24. Will you divide by 2? Yes, 6. 6 upon 12. Again divide by 2. 6 1 is 6, 6 12 is 6 2 is 12. So minus 1 by 2 is the answer. Okay, very good student. You are right. You are perfect right. Yes, you can multiply or divide and you will get a new answer. It is called the equivalent fraction. Now positive and negative rational numbers. Consider the rational number 2 upon 3. Both the numerator and denominator of this number are positive integers. Such a rational number is called a positive rational number. Yes. Second thing, negative. The numerator of 3 upon 5 is a negative integer, whereas the denominator is a positive integer. Such a rational numbers are called the negative rational numbers. Yes. So same way as positive, negative also there. Is 5 a positive rational number? Yes, my dear student, it is right. See, is 8 upon minus 3? Is 8 upon minus 3 a negative rational number? Yes, we can know these things. Because how to get it? Very simple. We can multiply 8 into minus 1 and minus 3 into minus 1. We are multiplying both the numbers minus 1, and then we can get minus 8 upon 3, because minus 3 into minus 1 will give us a 3. Negative number multiplied by negative number gives us a positive number. Vice versa, positive number multiplied by negative number will give you a negative number. Correct. The number 0 is neither a positive nor a negative rational number. That's why here we can specify only rational number. No positive, no negative. Okay, beta? Yes. We are knowing these things. 0 into any number will give you these things. You will see that 3 upon 5 will give you a 3 into minus 1, 5 into minus 4, or 3 into 1, 5 into 1. 3 upon 5. It's a positive rational number. When you want to get the negative, you can multiply with minus 1. Then you will get minus 3 upon minus 5. That time both numerator and denominator will become a plus. Not directly, but by multiplying minus 1 and dividing minus 1. The final answer remain the 3 upon 5 will remain the positive only. Try it for the other ones. Try these things. I hope so. You will get it idea. What is the answer? Regarding other examples, try it. Rational number on a number line. Students, you are knowing a number line, rational numbers can be written. Just simply draw a number line as it is. Positive on right side, negative on left side of the 0. Only the whole numbers. You can write it now. We are not starting the rational number. How to find the rational number, students? Yes. The points to the right 0 denoted by positive sign, and the points on the left side is denoted with the, yes my dear student, negative sign. Suppose I want to specify minus 1 upon 2 on a number line. That means from 0 to minus 1, it is divided into 2 parts and half part will be selected. So how to denote this one? Minus 1 by 2. Same way for right side. Here is the example of both the one minus 1 by 2 and plus 1 by 2. Plus 1 by 2 will come on the right side of the 0. 0 to 1 divided into 2 parts. That's why here written 1 by 2. Same way from here you can say minus 1 by 2 on the left side, but answer remain between the 0 and minus 1. Student, same way you can write minus 3 upon 2. Minus 3 upon 2, that means 2 upon 2 and 3 upon 4. That means 1 by 2. 1.5. Isn't it? So whatever the numbers are there, you just simplified and get the answer. Same way, minus 4 upon 2. Simplified, that the answer is minus 2. Okay, now you will get more a clear idea regarding this one. 0 upon 2 will give you a 0, minus 1 upon 2 will give you a minus 1 upon 2, minus 2 upon 2 will give you a 1 minus. Here is the minus sign. Student, by mistake it is not written here minus, but you are knowing now very well. This 2 ones are 2, 2 ones are 2. Isn't it? Clear. Very good. Here 2 2s are 4, 2 ones are 2. So answer will be a 2. So 3 upon 5 will be the answer of minus 5 upon 2. Where will be it is there? Just as shown here. Okay. Now rational numbers in a standard form. Standard form is nothing, but you should have to check. Is it possible to simplify it or not? A rational number is said to be in the standard form if its denominator is a positive integer and the numerator and denominator have no common factor than more than 1, other than 1. Isn't it better? Yes. Try to simplify it. You can check out the relation between the numerator and denominator till the factors remain 1 common. Not other factors can be common of numerator and denominator. Clear? Very good. Good student. Now look at here, lowest form. You use the word a lowest form, simplified form or a lowest form. We divided this numerator and denominator of the fraction by the same non-zero positive integer. Suppose 6 upon 10 is there. That means 6 is equal to 3 into 2 and 10 means 2 into 5. Now 2 will cut. What is the remaining there? 3 upon 5. Like as a equivalent fractions or equivalent rational number, the answer also like that way till the 3 upon 5. Numerator is 3 and denominator is 5. There is no other common factors rather than 1, because 3's factors are 1 and 3 and second one 1 and 5. Or you can say the numbers will be a prime numbers. Now you got the idea what is the importance of a prime number. Look at here the example number 1. Reduce 45 upon 30 to the standard form. 45 is the numerator and 30 is the denominator. Like as we are knowing, in place of 45, can we write divided by 3? Both the numbers can divide by 3, divisible by 3. Okay, now what will be the answer? Very simple, 15 upon 10. Okay, again 15 upon 10, having the common number, common factors. Yes, 3 then 5. This is number also can be divisible by 5. So 15 divided by 5 will give you a 3 and 10 divided by 5 give you a 2. So final answer is 3 upon 2. 3 and 2 both are the prime numbers. Or you can say numerator 3 and denominator 3 have the common factors 1 only. So you can say 15 is the HCF of 45 and 30. Now you can remember we already studied about LCM and HCM, lowest common multiple and highest common factor. So check out the both number 45 and 30. 15 is the HCF of that number. You can divide directly with this number. Then you will get the final answer within a second. So number of time I said you should have to divide with a HCF of the numbers. You will get the reduced form. To reduce the rational number to its standard form, we divide its numerator and denominator by their HCF, ignoring the negative sign. If any, it is there. The reason for ignoring the negative sign will be studied in higher classes. If there is a negative sign in the denominator, divide by negative HCF. Be careful here. HCF means highest common factor. Yes, there are two methods where the prime factorization and divide method, latter method. Example number 2. Reduce to standard form. 36 upon 24, second one 3 upon 15. My dear student here, first of all find out the HCF of 36 and 24. 12. Divide with both the number, you are having the 3 upon 2. Answer is 3 upon 2. Correct it? Because minus 36 upon 24. So answer is minus 3 upon 2. Second one 3 upon 15. 3 upon 15 is 3 divided by 3 and 15 divided by 3. Will give you a 1 upon 5. Minus 1 upon 5 because the number was there initially minus 3 upon 15. That's why here. See the example, try this. I did it here 2 upon 5. Clear? Correct. Look at second one also 2 by 3. Because 6 2s are 12 and 6 3s are 18. Comparison of rational numbers. Comparing the rational numbers. Have it? Which is the smaller or greater? Comparison means either it's smaller or greater. So two numbers are there, 2 upon 3 and 5 upon 7. How can you compare this number? If suppose there is a number 5 and 3, you can immediately say 5 is greater than 3. But here number is rational 2 upon 3 and 5 upon 7. We cannot say directly the answer. We should have to make the denominator equal. By what is the LCM of this, the denominator 3 and 7? It is a 21. 21 means you can multiply 7 with first number and multiply 3 with the second number. Now you are having the 15 upon 21. Yes, and 14 upon 21. 7 2s are 14 and 5 3s are 15. You are having now the numbers 5 and yes, positive and negative, you can say immediately the answer. Final answer, positive number is always greater than negative number. But whenever the both are the negative or both are the positive, you should have to say which is the greater one by converting this fraction or rational number into equivalent denominator. Both the denominator remain the same. Clear? So immediately we can say minus 2 upon 10 and minus 5 upon 10 both are the same. Here, look at the picture. See minus 1 by 2 and minus 5 by 10. Is minus 1 by 5 greater than or not? So I can give you one small thing. Whenever the both are the negative, a smaller negative number is greater than bigger numbers. This we are knowing. Same way, we are having minus 3 upon 4 and minus 2 upon 3. My dear student, here you can find out the LCM of 4 and 3. Denominator का LCM लेने का है, numerator का नहीं. Okay, so what is here? Minus 9 upon 12 and minus 8 upon 12. So 9 is smaller than 8. That's why we can say minus 3 upon 4 is smaller than minus 2 upon 3. My dear student, same way here positive numbers are there, 1 upon 5 and 1 upon 2. Check out who is the smaller denominator will remain the bigger one. When the numerators are same, denominator bigger is smaller one. In negative numbers, vice versa. Yes, we are playing with the balls, throwing the balls. If you throw on the ball and if you press it, it will go back to the back side. Same as minus 3 upon 4 wala. The case of a pair of the negative irrational number is a similar to compare two negative irrational numbers. We compare them ignoring their negative sign and the reverse the order. How can we do this one? Yes, remove this one. Multiply with 3 and 5. What will be the answer? 21 upon 15 and 5 5 is 25 upon 15. Now both the denominator are equal, 15. Which number is greater, 21 or 25? 25. Correct. So which number is greater? 5 upon 3. So put the sign 5 upon 3 is greater than 7 upon 5. The both number are smaller, but then check the denominator compulsory. See, all four numbers are different. So don't afraid about this one. Make the denominator equal by taking the LCM of the denominator. Yes, my dear student. Or you can say cross method. ये number से उसके साथ multiply कर दो, you will get the final answer. Comparison of a negative and a positive rational number is obviously a negative rational number is to the left of 0, whereas a positive rational number is to the right of 0 on a number line. So, a negative rational number will always be less than a positive rational number. Easy? Would you like to check out the positions of these numbers on number line? Yes, now you are very practicable student to denote positive number and negative number on a number line. Here is the example number 3. Let's we check out. Do 4 upon minus 9 and minus 16 upon 36 represent the same rational number? Let's check it. 16 upon 36. And we write here 4 4 is 16. Yes, divide by 4, that means 4. And 9 4 is 36. Minus 4 upon 9 and 4 upon minus 9. Both the remain same. 9.8 natural number between two rational number. This is the most important part of this lesson. And last topic we can discuss today is Reshma wanted to count the whole numbers between 3 and 10. From her earlier classes, she knew there would be exactly 6 whole numbers between 3 and 10. Similarly, she wanted to know the total number of integer between minus 3 and 3. The integer between minus 3 and 3 are minus 2, minus 1, 0, 1, 2. Thus, there are exactly 5 integers between minus 3 and 3. Is it here? Correct. Are there any integers between minus 3 and minus 2? No, there is no integer between minus 3 and minus 2. Between two successive integers, the number of integer is 0. Successive means एक के बाद एक वाला. 2 and 3 के बीच में कोई number नहीं रहेगा. Integer number. Thus, we find that number of integers between two integers are limited. Find. Will the same happen in the case of rational number also? Check it. Resma took two rational numbers 3 upon 5 and 1 upon 3. First of all, we can make it a equivalent fractions or equivalent rational numbers. So we will get here 9 upon 15 and 5 upon 15. So between 9 upon 15 and 5 upon 15, can we write like this way: 1 upon 3, 6 upon 15, 7 upon 15, 8 upon 15, 3 upon 5. Or you can write 5 upon 15. Why not 5 upon 15? Sure. 6 upon 15, 7 upon 15, 8 upon 15, 9 upon 15. How many are there? Yes. There are number of written rational numbers. 5 upon 15 की जगह पे लिख दिया आपने yes, and you can make the other numbers also. This is 5 upon and 9 upon, this 2, another term A1, 2 and 3. Can we write here? Yes. My dear student, it is clearly written. It is possible to show it. Shall we conclude our today's session? Thank you. Take care. Be safe.